So we'll carry on with the second half and two more speakers, starting with Andrew Krause, who joins us from Durham University and is going to talk to us about his experiences as a nearsighted man.
Thanks very much. As Francesca said, I am also partially sighted. I didn't know this term, partial sightedness, until a few years ago, in fact, because I grew up what I would call legally blind in the US. I was born with optic nerve hypoplasia. So in this talk, I'll have two kind of disjoint bits. I'll tell you a bit about myself, a bit about sort of my disabilities, how they influenced my history, this sort of thing. And then I'll have some, let's say, controversial comments about the future of what we're doing as math educators, which I'm intentionally marking these as controversial because I would like you to argue with me. I would like this to be more of points of discussion rather than me telling you what I know the future will look like. For the first point, really these 2 points, the first one really is that disability, particularly visual disability, but all disability, is a rather complicated, multifaceted, personal spectrum. So quite a lot of what Francesca said, I overlap with, right? I use this device to see talks and to see lecture notes. It allows me to see a tiny bit of the screen. The image that was shown of the lists of things in a grocery store aisle, how normal people would see it or visually competent people would see it versus how someone with albinism would see it, it's very similar for me. There are some differences. So really my disability is extreme nearsightedness. I can't see any of the text on the slide behind me. I can just see sort of lines where the text would be. But often people interacting with me don't necessarily notice that I have this visual impairment because it doesn't affect my ability most of the time to sort of navigate moving around. It does mean that I can't flag down buses because I can't see the number, right? And I can't drive. So not being able to drive was quite a severe disability in rural America where I grew up. I grew up in a town of 3,000 people. We lived very close to the store. It was 3 miles away. So coming to the UK was sort of life-changing 12 years ago. I was like, wow, healthcare, wow, public transport. Anyway, so I mention this in particular because your view of disability, your view of your own identity changes tremendously based on who you grew up with, how your sort of culture views you. So my parents, I love them, they're great people. They voted for Trump. They're very conservative, working class Americans, right? So what that means is I sort of didn't really consider myself disabled as a student. I didn't know you could get someone to take notes for you until I was lecturing. Right? And what this meant is that when I knew that I could use a device like this to see, when I could take advantage of this fact, I didn't really learn to take lecture notes because I can't do that while I'm focusing on one bit of text at a time. So what I would do is I would grab the textbook for the course. So in the US, most mathematics courses, most courses are taught via textbooks, and I would read all the textbooks in the summer before, right? And I was very sort of self-motivated, very engaged with the content. I think that was a bit more of a cultural thing there to really throw yourself into your studies in a way. It's not very often in the US that you have bespoke lecture notes, things like this. And so it gives me quite a different perspective on how UK students are taught, the sorts of things they're taught and at what level. Mathematics as a field is a little bit conservative. So one of my favorite examples that I wrote about in my PG cert thesis is that there's a textbook by De Morgan in 1840 on differential and integral calculus, and this A-level syllabus is more or less in that textbook, right? The introductory calculus textbooks in the US, most US universities have a Calculus 1, a Calculus 2, Calculus 3. They all use textbooks which are morally identical to this 1840 textbook. And I think that this impacts a little bit the way that our field operates in how we teach, how we sort of think of content, how we think about expressing ideas and communicating ideas. So again, my first point is really that we are all rather unique. I think we're all kind of aware that academics, particularly mathematicians, are highly neurodivergent in very diverse ways. We're all kind of weird in our interesting and unique flavors of weird. But I think this is true as well for disability, and it's true as well for how we best understand something, how we best approach content, how we best approach sort of concepts, intellectual concepts. So for me, listening was very important. Being able to read tremendously was very important. So unlike several colleagues I know who are also partially sighted, I have no, let's say, stamina with respect to reading. I can read as much as I want. I just need to be very close. Another point that's different from what Francesca said is large font is actually usually more difficult for me to deal with. So when I did standardized tests as a student, the state would occasionally know that I was visually impaired, so they would print out these giant exam papers, which were a pain because I would still bring them up to my face in order to see them. So it was more difficult for me to deal with exams printed in large font than it was if it was just a normal exam paper and I could bring it in front of my face. So things like my phone are actually much easier for me to use than most laptops because I can bring it very close to my eyes, right? But there's this uniqueness to the disability, or this uniqueness to the way that we cope with it, which I think is rather individual. You get this even with people who are completely blind. They will have a preference of screen reader. They will have a preference of the way that they like interacting with certain amounts of content. So I'll transition now to my second bit of the talk, which is a bit of a contradiction, right? To paraphrase Walt Whitman, I contain multitudes. I will now talk about why we should do everything using visual web accessible sort of content. So this will be a bit strange, and again, I think that I'd like really for this to get at conversations about the way that we think about mathematics and conversations about the way that we write material. So there has been, and I think Christian will talk quite a bit about HTML and web accessibility. There has been a big shift to web accessibility. From my point of view, the biggest aspect of web accessibility that makes it really good is that it allows you to make lecture notes that different people with different impairments or different ways of seeing the world can play with themselves. So for me, again, I don't usually like people to write in large fonts when they send me things, but I really like lecture notes, like Alex's lecture notes here, because if I prefer to see them in light mode or dark mode, I can do this. If I have any sort of dyslexia, I can use apps that sit on top of a web browser that will help certain aspects of dyslexia by bolding certain letters. There are lots of tools for these sort of things that the individual can personalize to themselves. For me, I will, depending on what screen I'm using, I will modify the fonts, I will modify the size of whatever I'm looking at, but the point is I can control it. I'm not asking the lecturer or whoever's prepared the material to produce content that is specific to me, because I know that the way that I consume content is rather distinct from the ways that other people do. And there are non-trivial aspects of this. There again is no silver bullet that solves all of these problems, but I do strongly think that the web, specifically HTML5, canvas tags, all of these rather new since say 2012 technologies, have allowed a level of accessibility that we didn't really have before. LaTeX PDF are accessible from some point of view, but not compared in any sense to HTML. Right, so I brought this up just because this is, I think, Alex's notes, right? But I'll show you a few other examples of this. One thing I want to comment on is that our students spend a lot of time, particularly in A-levels, many secondary schools, spend a lot of time on this website. So the vast majority of first-year students that I interact with, when I ask them, what do you do when you want to plot a graph? They will not say, I take out a piece of paper and I start drawing. They will say, I pull out my phone and I go to Desmos, or I go to GeoGebra, or I go to one of these websites that does quite a lot of mathematical visualization for me. And one thing we don't do as university educators, as much as we should, as much as particularly A-level teachers, I think, do a better job of this, at least those I know, is take advantage of this, right? We say, well, we want you to be able to do it in a closed book, 3-hour exam where you don't have your phone. But what we don't do is say, well, we can still use this. We can still take advantage of this tool to help you learn how to graph things, to help you learn how to solve algebraic equations, to really take advantage of these powerful technologies. When I was, say, 11 years old in the US in something like middle school, I had an algebra instructor who made a comment all the, you'll never have a calculator in your pocket at all the time, right? It's kind of funny now, but the point is you do have really a supercomputer in your pocket. You can do things that were unheard of 30 years ago, right? Immediately on your phone. And we should, I think, to a large degree, take more advantage of this in the ways that we think about curricula, in the ways that we think about education, really in the ways that we conceptualize mathematical thought. So I won't go through Desmos in a lot of detail, but I really do think it's something that if you haven't played with it, if you don't know what it is, I would strongly encourage you to at least play with it and get a sense for how your students use it, for how they think about it. It has a range of accessibility features. So I gave a version of this talk a few years in Glasgow, and I made a comment about Desmos, and I didn't know that it had a ton of accessibility features. And this was pointed out to me, and it really does. It really has quite a lot of support and quite a lot of ability to do things that aid a variety of different visual and other impairments. So it can be done in a way that is useful and at least to some degree is inclusive. So we use it in lecture notes. So this is a set of lecture notes that Adam Townsend at Durham, Chris Pryor, and myself have written. And in our lecture notes, we do a fairly gratuitous use of links directly to Desmos. So this is an example of discrete time dynamical systems. And this is an example of the logistic map, which has a very beautiful bifurcation structure to chaos, which is all very nice. So if I click on this link, I'm led to this plot. And this is something that students often have a little bit of trouble plotting. So the idea is you plot a function in green, and you plot the line y equals x. And then to understand the flow of the dynamical system, you match these up by picking an initial point, going to the green line, going to the I think it's a blue line, then going to the green line, going to the blue line, and these sequence of points that you draw out are the flow of this map. This is something that we emphasize in dynamical systems quite a lot. Just as an aside, despite being born visually impaired with nystagmus and this sort of thing, since I was very young, I've always been an exceptionally visual person, and I've always really liked geometric ideas. And so I always think of dynamical systems, which is my sort of area of research, as a geometric or as a visual thing. And it's sometimes hard just on a blackboard to get this algorithm across and to really build intuition of what these flows look like and how this all operates. But to some degree, it's at least a bit easier if someone can sit there on their own, on their phone or their laptop and play, and they can really get something out of the device. Of course, they should be able to do it with pen and paper as well, but to actually build the intuition of how these maps function, of how the sort of object behaved, being able to interact with it directly, I think is quite powerful. So here, for instance, I'll just use my finger and I'll move the initial condition, and you see that it changes the shape of the thing. And then perhaps more importantly, I can move the parameter value, and I can see a sort of bifurcation structure, and then eventually you get this sort of bifurcation to chaos where the value of the initial condition changes the behavior, right? So there's a bunch of interesting mathematics here that we like emphasizing. This is a different visualization of the same structure. So here now the red is the graph of the function, and it's not plotting the diagonal, but it's just showing the iteration of the map. And I can press this, go to the map iterating, and then I can plot the value of the single dynamical system on the bottom. And you can look at different visualizations to understand sort of how this process works, right? And the point is, if you don't understand this after I lecture in a course, that doesn't matter. You have a link, you can go away and play with it. You can go away and sort of understand it yourself. And I think this is true with a lot of what we teach, that we're not really expecting expertise. We're not really expecting mastery after a lecture. We're expecting mastery after someone has gone away and they've struggled with it, right? This Vygotsky's zone of proximal development, this idea that learning really is in this area where we struggle, where we're sort of just beyond our abilities, just beyond things we've mastered. once we're truly struggling in the right way, in a productive way, that's where we get the most out of education. For mathematics, that mostly happens either in discussion or in at home working through the material yourself. It doesn't as much, from my point of view, happen in lecture, right? There's a lot of struggling in lectures, but that doesn't necessarily make the most productive time to master or really capture all material. Okay, I think in the last few minutes, is it 20? What time am I ending?
Yeah, 25. So you got 15 minutes, 14 minutes.
Okay, I won't take all of that. The last thing I want to comment on two other things. So one other thing is that Dennis Patterson and I designed a course this year that we thought was kind of exciting. It was a very skills-based module in computational mathematics at Durham. And one thing we did in this module is for the last 4 weeks of the module, we gave the students a sort of group work assignment. We structured the group work in a certain way that we hope was useful, although some comments this morning for encouraging the use of chat and encouraging alternate modes of communication will be very useful. One thing that we did, which is very atypical in a mathematics course, is part of their mark, part of what we asked them to do, was to go away and do something interesting that they found where they could express themselves creatively. This was possibly the most fun I've ever had marking an assignment, was looking at some of the assignments these students produced. So if you're interested, you can go to this website, and we've put these all, with the students' permission, we've put these all, these videos on the website here, and I won't show you all of them, but let me just show you what some second-year students were able to produce in a matter of a few weeks, because the technology is so good and they're so capable when sort of given freedom. So I won't play the sound here, but this is an example of one of these students who built this presentation as part of this course about a second-year student talking about rather non-trivial bits of maths, coming up with these rather elaborate animations. Again, I think the technology here is sort of the 3 blue, 1 brown kind of Python scripts, right? The student went away and they learned all of this, right? They did this all on their own. We told them almost nothing. We gave them the bare minimum introduction of how to make a video. And they were able to go away and do this kind of thing when given time and encouragement and an emphasis towards doing something creative. So I won't show a bunch more of these, but my point is our students can do some really incredible stuff when we, let's say, change the focus a bit towards letting them explore what they really want to do, what they're really capable of doing. Okay, right, sorry, I'll stop being so political. The last thing I want to comment on is something that I've worked on for the past few years. This is a bit of technology that, again, in a website allows you to do kind of hard mathematics. So without going into any details of what a partial differential equation is, it's one of the big motivations for supercomputers historically, one of the big motivations for the development of high performance computing worldwide. So because of essentially more capable web browsers and more capable graphics cards, we built a website that allows you to do what 30 years ago would typically have required a large cluster or a supercomputer. This can now be done on your phone in a web browser instantaneously. So the point of this website is to solve these equations live rather than running a 3-month simulation. So here's an example of just a set of equations that forms patterns. Again, this is sort of closer to my research. I can click to say make initial data. I can run the thing. I can go through and I can change the equation live, update the mathjax that appears on the screen, sort of see how it behaves. I can do things which matters for applications. It particularly matters for non-mathematicians who also use these models. So in my case, this is typically biologists or engineers. I can change the parameters in a way that the system responds live. This is related to quite a lot of scientific computing research. I won't really go into this. This is a fairly niche topic, but this kind of technology, this kind of web accessible thing, I think is very powerful. It's also very powerful from the point of view that I can now click a button and I can copy a link and I can send that link to a colleague that's this precise simulation with these parameters, whatever it is, right? I can change any of these equations on this website and turn them sort of into any other thing. And there's value in being able to create these things. There's value in being able to make interactive web-based technologies. So another example of where we use this is a colleague of mine, Benjamin Walker. He's written a nice set of HTML lecture notes that again have many of these features. So I think if I go to his HTML lecture notes, I can swap between dark mode and light mode. I can change the font, do whatever I want. I can go through his typeset, his very nice typeset lecture notes, and then I can embed these interactive simulations of these models in various ways. And everything here is sort of live, right? The sort of mathematics aren't just images or videos or still things. They're sort of living, breathing objects. There are a growing set of what I would call visual lecture notes. Another one that I didn't bring up here is something called visual complex analysis. I'd recommend taking a look at it. It's a very interesting way of introducing and describing particularly quite a lot of the geometric or quite a lot of the sort of visually analytic structure of complex functions in a nice way, taking advantage of other media besides just text, right? So I think I'll end with this point that I think we need to have somewhat non-trivial discussions about accessibility and inclusivity. We should also think about what precisely are we doing in how we're communicating mathematics, and can we take advantage of a lot of this stuff to change or introduce other modes of describing maths. I'm happy to take questions. Thanks very much.
Thank you very much, Andrew, for a really fascinating talk.
Do you think we should teach how to use this technology? You kind of gave them free range and they did it themselves. Do you think we should, particularly things like Desmos, is it better for them to have freedom? Should we actually teach them how to use this?
So the question is, should we teach the students how to use this technology ourselves? I think so, yes. I think maths, so my department, and I'm certain every department, is constantly arguing about what the important curriculum is and what should we take out of linear algebra and these sort of conversations. So there is a question of room and space and that sort of thing. I absolutely think that if we need to introduce, or if we have the ability to introduce technology or the ability to do and create things into mathematics educations, we should. We really should, I think, be running, at least within the staff, professional development seminars on how students are using Desmos. And there is an aspect that I say most A-level teachers are using it, but possibly not all of them. And so this does lead to inequality in terms of some students will be more immediately capable of using this stuff out of the box, and some won't. So there is some value in having a single lecture or a bit of a first-year course saying, here's a bunch of cool technologies, here's what Wolfram Alpha is, here's what Maple is, whatever these technologies that we decide are important. Embedding these within our curricula as much as possible, I think that there's an advantage of this. I constantly get a bit of pushback when I try to say we should really modernize math from the 1840s. But I think there's value. I think there's value in students being empowered via technology. Yeah.
Yeah, so the question is there a good way to turn a text file into an HTML file?
No, I would say no. I think Christian will likely talk a lot about this. I think there are at least 5 distinct ways, maybe more, that you can do this. It's a complicated beast. There is a level at which you are better writing in a format which is less explicit about typesetting than LaTeX. So there is some value, and Christian may have a different opinion here. There's some value. So our university has kind of decided that internally people should be writing in Markdown rather than LaTeX because Markdown is easier to translate to different formats. I don't know. I don't have a strong opinion on this. I think there are a number of tools that do a pretty good job. So there's Chiron, there's the guy at Sheffield, what is his technology? Vincenzo. Leeds, BookML. Sorry, Leeds. I'm sorry. Yes, BookML. Sorry, yes. BookML is a fairly okay one. It depends a little bit on all the details. So if you write plain tech, any of these packages will work fine. If you have the most plain vanilla thing, if you include AMS maths, or you include a package that does something, then this becomes harder. So in general, taking text to HTML is difficult. The websites I showed you, the one Dennis Patterson and I wrote is in Quarto. The one that Adam Townsend and I wrote, that was in LaTeX, and then it was turned into, so Quarto sits on Markdown. The one that Adam Townsend and I wrote is in LaTeX, and then Adam has a bespoke Python script that goes through, I can't remember the name of it, but it goes through one of these, I can't yeah, but there's a machine, a black box that will take in tech at some level and will process it at some level, and this can be turned into HTML. This is, I would say, mostly still a faff. There are some one-click buttons that do it.
Thank you. Do we have any questions online?
Going with your project module sounds really interesting. Did the kind of outputs, were they all digital, or did some people, were they kind of more physical? Or?
It's a good question. So the module had 6 sets of e-assessments, 6 content weeks, I would say. And then it had 6 notebooks that the students wrote. These were all LaTeX documents that we gave them an overlay file. They would copy this overlay file into their account, and it would have essentially a question, and they would fill in the answer to this question, which typically involved going away and writing some code and doing some computational mathematics, and then taking the outputs and putting that in and describing the outputs. They did this for 6 weeks in order to essentially build up skills in using a computer to do mathematics. And then once they had those skills, we then had 4 weeks of a project component. That project component involved producing a 5-page group report on essentially a set bit of material. So for example, I ran a topic in stochastic differential equations, one lecturer ran a topic in knot theory, and using a computer to play with these planar diagrams. One project ran on percolation theories, so there were a variety of different projects. The students did their set component, produced 5-page LaTeX reports, and then the final bit that I showed off was an individual extension of that project report. So given that you've done something in this topic, now you go away individually and you produce a 6-minute video and a 2-page report. So we made the students work hard. They did a lot of work. We got a lot of complaints about the workload, but they were happy at the end. They all were super, super proud of saying, I just did something really, really quite made all this stuff, right? All of these reports, all of these documents. I think it was really the bit I showed were these 6-minute videos, I think were the main thing. Could they make other things, not in the rubric or the syllabus of our module, but that's an idea. Why not allow them to do, even broader ideas than some digital video?
We've got one question online about saying, what are your experiences of using AI as a tool to support learners?
Yeah, it's a complicated question. So part of this is the vast division and opinion about the use of AI in mathematics, I think. So there are people in my department that are, I would say they've drunk the Kool-Aid. They're using it for everything, and from their research to their teaching to everything else. There are some people that will not touch AI at all for ethical reasons. I am generally pro AI from the coding point of view and a few other things, but I think it's complicated. I think the current landscape of large language models is interesting, and I think there's value in most of us paying some attention to it. I have not used it. Let me say, I have used it for Quarto to make HTML lecture notes. I have used it to help assist some of the tedious faffing of turning something that in my head would be LaTeX into something that would be HTML. It does a fairly good job of fixing my mistakes and that sort of thing. What I've not done is I've not told students to use it. In our computational module, we did not ban AI. We did show them how to use it. So we taught the module within MATLAB, and MATLAB by default now ships with a model of Copilot. And so if you press it and it's like Control-Shift-P, you bring up a prompt and you can just say, write code to do this. So we showed the students how to do this. And I was very fortunate in the first lecture, I asked it a question to do something analytically, and it did it perfectly correctly. It wrote in symbolic MATLAB how to compute some line integral. And then I said, now can you do exactly the same thing, but use a numerical method? And it wrote code that gave the wrong answer. This was excellent. This was great teaching because it immediately pointed at the pitfalls. I can't reproduce that every time, right? But it definitely helped get across that you can't use these tools blindly. Our department is still arguing a bit about using AI at all and what policies we should have. In our computational maths course for next year, we're going to be at least a little bit clearer about good and bad uses. We have quite a bit of signposting in what's sort of allowed. Generally, we're fairly happy if students use it, but we have to be a little bit careful that if they're using it naively, then really what they produce in the end is quite bad. If what they produce in the end is perfect, then we don't care how much of it was them and how much of it was the AI. But I would say that's a rather personal choice that the other lecturer and I have that quite a few members of our department disagree with. Yes, I think at the moment AI is a bit of a can of worms. I think there are a lot of good possible futures. There are also a lot of scary futures, particularly given the involvement of companies and all kinds of other things. I think that is a conversation we should keep having.
Okay, so that's thank you, Andrew, again for his talk and his questions.